Hey everyone, today we are going to talk about a new type of AI vulnerability, model inversion attacks. We're going to explain this attack through an example. Let's say we are a malicious actor looking to plan a heist. We know that there is an AI model for facial recognition software on the company we're trying to get around. Well, one way we can try to find out if our image is already in their image software is by conducting a model inversion attack. We can send a pixelated, fuzzy, nonsensical image to the model, and the model can tell us if it's us and what confidence it thinks it's us. Well, then, once we have this confidence, we can make a few alterations and then send it back. And then if the confidence score is even higher, and we can keep iterating until we can have a pretty good idea what the image is. You can see right here, we're trying to guess if Where's Waldo is in the training data of this image classifier. We send it a fuzzy image and we get back a distorted image, but an image that's close enough that we can see that Waldo is in fact part of the training data for the model. So that's a brief overview of how the attack would work. Now let's show how we're going to do it through a coding example. We're going to start at the beginning, just providing some header information. That way, if we or someone else comes in later, they'll know what this file is and they won't have to spend a lot of time trying to make sense of our code. I do this part in all our videos, creating a baseline MNIST handwritten classifier. If you've already seen this part or know how to do it, you can fast forward to the code part for the attack itself, or you can copy the code from our GitHub page. If you don't want to do either of those, just keep watching and then we'll get to the code for the model inversion attack. Got our imports here. You see I did pip install TensorFlow. This is because I am working in a Google Colab, which is a Jupyter framework, and I need to do that, but you may not have to depending on your environment. Next, we're going to get the data. We're going to download it from the MNIST location. Then we're going to alter the data and then see what one of the images looks like. You can see sometimes there's some code suggestions. This is because Google has an AI agent that gives coding suggestions. It can be useful sometimes, but sometimes also the recommendations have some errors in it. Feel free to use it. We use it sometimes. However, probably not going to use it for this video because it gives us a lot of errors. So you can see that's what a handwritten 5 would look like. That's one of the images that the model is trained on looks like. Next, we're going to create a function. That way we can expedite some of the process in the future and don't have to write it all every single time we use it. I like to add a little bit of header information to each of the functions. This again just makes it easier for us or someone in the future reading our code to know what we're doing instead of trying to figure out what some magic function is. All right, now we're going to create our model and just get a baseline one and see what its baseline accuracy is. All right, we'll train our baseline model. You can see it has a model accuracy of 87%, which is fine given the limited data we gave it. Now let's get to the code of the model inversion. The first thing is a loss function. Remember, when we sent a fuzzy image to the model, we're collecting the confidence score that the model thinks that fuzzy image is the image that we are trying to verify. We're going to take the negativeness of this, so we're going to try to optimize the confidence that our image is the image we are looking for. I picked the target class 3. You could have picked any image. That 3 is just us hard coding it for this single video. Again, we're doing negative prediction because the prediction is going to give a negative confidence. We want to maximize the possibility, the confidence score that the image we're giving it is the image we are trying to find out if it exists in the training data. Let's perform the inversion. We'll give the target class, number of times we want it to run, and then the max iterations, and lastly, which algorithm we're going to use. There are a couple different types of algorithms you can run for this attack. They depend on the type of data you're working with, how well they work. We found that the POW algorithm worked the best, but there are a couple of different ones that you can try. So we have this best image, is just a bunch of random pixels at this point. And then infinity is just negative infinity confidence. We're going to loop through this. So we're going to have that noisy image. There's that minimize function. There's our loss function. Then that best image, which is that image we have at the beginning. And then the algorithm. Again, there are a couple different algorithms you can use. We're going to use the POW algorithm. And then the max iterations. If the image that we altered has a better confidence than negative infinity confidence, that will be our best image, and then we will continue to iterate upon this until we increase our confidence. This is one way to do it. However, you run into the problem of it maybe never getting past that initial confidence, maybe ceiling. A way around this would be to use a new image every single time. It is a way that might work better. It's not the only way. This is the way we're going just for this video. All right, let's see if there are any errors. There's always errors. Now, running this attack is going to take a long time. So once we finish the errors, we're going to hit pause in the video and come back after the first iteration. You could expect this to run for several hours. And we'll see what the best image we came up with is. Some more errors. Let's fix that. All right, this has been a couple hours. You can see there's the image. It looks like a 3, not a perfect 3, but it's a 3. And we were able to guess what the training data looks like, and we were pretty close. Now, this has been an academic example, but this is a real attack you should be aware of as a cybersecurity professional. If you're training a model on financial, health, or personally identifiable information, attackers can use model inversion to find out what that data is that your model is training on. Hopefully you found this video useful. Subscribe and like, and look for our code on GitHub. Thanks.